All right, we're back. Sorry about that. Had a couple of software updates I had to do, which was causing some processor usage. Not to mention the fact the room was just getting outright hot and causing the computer to get warm. But we left off here with this right here. Let me get this adjusted here. There we go. With this right here. So we got some information here. Um, a person with a first and last name, an age, a height, a weight, all of it being outputted. And I think the last thing I mentioned and stuff was the fact that this can be something that a program that can be used at maybe a doctor's office. But after thinking about it for a little bit, I think this can probably be used at multiple areas. For example, employees, it may not be height and weight and age. It may be background, education, age, name, um, whatever. I mean, so you can pretty much have whatever kind of data you want as far as this top section is concerned, and then anybody with proper access to it can have access to it through the bottom part of this program here. But that's just one simple aspect of this in programming. And this is how we kind of put it together, which is what this section right here is telling us about. Very simple stuff, but this right here section was specifically designed to display the variables, which is pretty much the data. Um, Now, here's another way we can do this. Instead of just people, what if we were to add things together? So let's say in a doctor's office, we need an average of something, average of weight over a person's period of time, height, um, maybe the person gets glasses or has surgery or whatever and stuff. And they've got a bunch of variables and stuff, or a bunch of numbers and stuff. They need to put it all together and stuff and see how it spans out over a period of time. Or maybe it could be an employee and stuff, and maybe their income or whatever it may be. Well, with this and stuff, not just can we put the data together like this. Let me go and clear this out here real quick. Start this kind of over. We can make these variables um, add together, kind of, and then do math with it. So the example here simply has something like this. Integer x equals 5. Uh, integer y equals 6. And then integer sum equals x plus y, sort of thing. And if we want to output that and stuff, obviously, instead of having everything outputted, we just output the sum. So if a person made this much this week or this much that week or had weighed this much whatever and stuff, I mean, and it could be anything. So let's say the something that comes off of an average. So the average house in a neighborhood costs this much. Or let's say you're trying to do a project and you're trying to build a deck or remodel a kitchen, and you need to figure up how much it's going to cost you before you do it. A lot of people would like to know those sort of things. So let's change these variables here. Actually, let's put the output out first. Standard out. And we're going to just leave it at that for a second because we don't know what we're going to do here. So let's take something simple. How about tires on a car? Okay, so we have the average car has 4 tires on it, obviously. So tires, which is 4. There are some that can end up with more, especially if you're dealing with heavier vehicles and stuff. Can end up with 6 or 8 or whatever. And the cost per tire. So cost And let's go with yeah, cost of tires. And let's say it's not 6, it's $90. Okay. Um, so we're gonna have to change this right here to where it's tires, and change this right here to where it's uh, and let's go ahead and mark this. So here's something else and stuff, those comments we were talking about. How many tires? Oops. And cost, oops, spell it right, cost per tire. Okay, so then we got tire cost. Spell right now. Okay. Yeah, cost tire. Probably name this something a little bit better than that, but we'll go with that for now. Now, you wouldn't exactly just add these two together and stuff, because if you add those two together and stuff, you're not going to get the actual cost of 4 tires. So instead of just adding them together, we're going to multiply them. 4 tires times the cost at $90 per tire. Okay, so we're going to have it to where it does this right here. 4 tires for new tires for my car cost, and then that's where you would actually put in, oops, the output operator and sum. At that point in time right there and stuff, instead of having to constantly do the math and stuff, all you would have to do is change if there's a different amount of tires. Say it's a two tire trailer. Trailer you're pulling along and stuff, or you want to get tires for the car and the trailer, or if it's a pickup truck that has 6 tires on it, you can simply change that right there to 6 instead of 4, and then change the cost per tire from 90 to whatever it is. So we're going to go ahead and save this, run the program. 4 new tires for my car cost $360. So now you know how much it would cost for that. Let's get another example in here real quick. So let's say here you got a deck you're trying to build, and you need wood for it, and it's 2x4s. And let's say you need a total of 50 2x4s. Okay, so let's see. We'll just put lumber in there for that one. Lumber, how much lumber do you need? And let's say you need 50 pieces of lumber. And for the comment, we're going to put in how much lumber is needed. That way we know what this stands for. Okay. And then we change this to cost again, except we're just going to put that away. And then we're going to put in here cost per 2x4. Yeah, 2x4. That's what they normally say it as. So there you go. And we're going to change this right here to lumber. And this is going to still be cost, but not tires. And we still got the same right here, the same thing. This is no different. The only thing we're going to change is this string right here, or this text. But we do need to change the value, because I don't think we're going to pay for $90 for one. But instead, it's going to be, let's say, $9.99. Well, we can't have a decimal for an integer, so we need to actually change this to a double. And unfortunately, since we're using a double for cost, cost is going to be right here, so the sum is going to end up being a double. So we're going to have to change this integer into a double as well, so it actually outputs a double. We'll get into the details of that later on. So now we got a proper cost. Okay, and so now we just need to change the string right here. So let's see, to build my deck for my house will cost, and then we got that right there. So then we can save it, clear out the terminal, run the code. To build my deck for my house will cost $499.50. Now we don't have any symbols in here to indicate anything else, but we could put that in there. This is where the char comes in place. That's why I was trying to find a way to stipulate that. So char. Chars can represent, and we haven't really got into that yet, but we'll get into that eventually. We're just kind of trying to see how we can add variables together in any output, or add variables together and make a new variable, which is what this right here does. We create a new variable to add two variables together. In this case, though, uh, we got another character involved because we want to see it actually a dollar sign in it. So we're going to have dollar sign equals, and with chars, as in it's kind of set up here, but it didn't give a whole lot of details. Chars kind of only take one quote, a single quote, not a double quote. So, and this is not a letter, this is actually a symbol, which is something that they don't really go over in this, but we're going to throw it in there anyways. So the dollar sign. Yep, there it is right there. And then end that. Now we need to adjust this right here to add that dollar sign in there. So it's not going to be just the sum. It's going to be dollar sign space input sum. Let's take a bigger look at this so we can see this. There we go. Now we can see the entire thing. And let's go ahead and save this. So now we got lumber, 50 pieces of lumber at $9.99 per piece. Multiplying those two together and stuff to get our total value, which we've already seen that before, but now we're adding a new thing in here, which is a dollar sign, so we see that. So the dollar symbol is going to go right there. So in this statement right here, it's always going to look like this. All we got to do is change the values. And run the code again. And there we got, to build my deck for my house cost $499.50. And you got the dollar symbol in the right spot. Just depending on how you put this together. And you can add more to this. I mean, manipulate this can go in so many different directions like this, but a lot of programs can do that. So what makes C++ different than a lot of other programs? We're going to get to that. We ain't there yet. Go and clear this out, downsize this. So we built this program right here. That's pretty much the end of declaring variables. So let's move on to the next step of this right here. Multiple variables, declaring multiple variables. Well, we've kind of already done that right there as it is. To declare more than one variable of the same type, use a comma to separate them. Okay, so in this case right here, we can actually do that as well. Is it normal? No, not really. This is actually a better way to put it because you can kind of add this right here to it. But if you wanted to do something like that, you would simply take this right here out, according to this example, take this comment out, step over that, put a comma right here, since they're both doubles, and then put in sum equals lumber times cost. And then you got two different ones, but that's a little harder to read, not to mention the fact you can't put a comment there. But let's see what this says here. To declare more than one variable of the same type, use a comma separated list. So, and it shows the example right there. One value to multiply variables. You can also assign same value to multiple variables in one line. Okay, so it's kind of given this example right here. Most people don't write code like this right here. I mean, they might, in some occasions and stuff, it does work. If we go to save this right here, it will still print out the same thing. See, you still get the same output. But in this case right here, if you have multiple integers and multiple doubles and stuff, then you can kind of do it a little bit differently. Let's go ahead and get rid of this right here. See if we can find an example where that works. I probably wouldn't myself do it this way, but it is possible. I mean, you might be able to find a use for it. So let's see here. Trying to think. We have, and let's go with the deck ID again. So we have the lumber. We have nails or screws. Let's just put nails in. Nails. And what else might there be with building a deck? Paint. Typically, people end up staining or painting a deck or whatnot. So that might be another thing. We'll just call it stain. And then end that. And in this case and stuff, we're going to end up, in this example, it actually has us writing x equals y equals z equals 50, but that doesn't really make a whole lot of sense, and that's not a scenario we're going to be putting together at all. So instead of having it, because I mean, in this case right here, every variable is going to end up being 50. The top scenario and stuff, we're kind of declaring three different variables at the same time: lumber, nails, and stain, but using one type instead of three. In this case, though, we are going to put it this way: lumber. Again, we need 50 pieces of lumber times cost, and we're just going to say flat out $5 a piece, plus stain. And let's say that's $25, equals sum. Okay, now we don't have anything declared for sum, so that's why it's not really working in this sense. But is there a way to make this to where it would work? Because right here, sum is not identified. It doesn't understand what sum is because we don't have a definition for sum. We've got an equation right here that has no meaning to it whatsoever. I'm not sure how that example would work at all, because I'm trying to figure out how this would work, and I'm just not coming up with any ideas. Maybe you guys can come up with some ideas on how this might work. Because the original example, like I said, is simply x, y, z, x equals y equals z, and it says no sum, but they're putting the variable or the value right there so that every variable actually is 50. So then when you output this right here, you should end up with 150. X plus Y plus Z, or if you want to multiply them or whatever and stuff, each one's going to be 50, so whatever you do and stuff. The variable is going to be 50 based on a value of 50. And then that to end it. Control save, and in this case right here, you're going to end up with 150 right there. But not everything is going to be the same all the time like this. But I mean, you kind of get the idea of that. It's just kind of showing you that's a way of doing something. I don't hardly ever see code run like that and stuff, but I mean, it's just another way of doing it. So it's just kind of demonstrating that. I'm not sure where that's going to ever be used. So let's go on. Okay, so we got another exercise. We're going to skip that and go on to the next part, identifier. All C++ variables must be identified with a unique name. These unique names are called identifiers. Okay, so identifiers can be short names like X and Y, or more descriptive names like age, sum, total value. So we just kind of went over that and stuff, all this. Note, it is recommended to use descriptive names in order to create understandable and maintainable code. So we kind of already went through that, so we kind of jumped ahead on that part. The general rule for naming variables are names can contain letters, digits, and underscores. So variable can contain, oops, let me put that as a comment, sorry. Variables can be letters, A, B, capital C, etc. Actually, we should rename this. Not can be, can contain, because that's a very specific word in that phrase. Variables can contain digits. Example 1, 3, whatever, etc. Variables can contain underscores. Example of an underscore, I'm sure most of you already probably know, is that right there. Let's continue that though. So a good example of something with an underscore in it. So you've been seeing people use, or me use this so far, my name. Well, what if it wasn't, let me write this right here properly. My name, example, a good example, my name, and we'll change it to underscore be my underscore name. So this is kind of demonstrating a different way of writing a name with an underscore, because you can't really have a space in there. In this case and stuff, if you actually had the space in there, I'm going to get rid of this right here, and this right here, my age. We're just going to declare it for now, but yes, you can change it to where it has an underscore age. But something you can't do is have it like that. And the reason that is and stuff is because, like I said, the syntax before and stuff was type, variable name, value. In this case, you have a type, a variable name, and nothing. So this doesn't work. The only way it would work is if you actually had the comma in there to separate them, or the underscore in there instead, space them out, or the capital letter, one or the other. So the next part of this and stuff is names are case sensitive. Okay, so that's where we got the idea of the whole case sensitive thing. So our case sensitive. Examples. Yeah. Examples. My age is one way of putting it. My age is another way of putting it. My age, I mean, there's so many different ways you can put that and stuff, but to address that and everything, have it all capitals and stuff. Like I said, the only thing you can't do is if you're using uh, the using namespace up here at the top, CD, and then you take this out right here, you can no longer use the word count or cout as the name because it's going to think it's part of this, which is kind of why we don't do that. But I mean, depending on your code and stuff, you may have to. You may have a reason for doing it that way. But anyways, so that's kind of an idea. Names cannot contain white space or special characters like, okay, so we already told you about the whole space right here thing. But they can also not contain anything like the symbols like that, that, that doesn't work. None of that does. Letters and numbers or underscores. That's pretty much your limit on what a variable can contain. So we'll put that in there. Variables can only contain letters, digits, and underscores. There's one more piece to this right here. These are kind of the rules of how you would how you can name a variable or how you can come up with a variable. So yeah, reserved words like C++ keywords such an int. So like this word right here, it cannot actually be a name. This right here cannot actually be a name. If you're using that whole using namespace, then that means this part right here can't be a name. So whatever is already used as a keyword or as a type or whatever cannot be used. So you cannot use double as a name. But there's an exception to that. So we said you can't use double as a name, but you can use my double, which is not the same. Because in this case now it's my double, it's not just double. We put in, no, we skipped one. I am sorry, we skipped one. We did skip one, underscore. We got 5 here, we got 5 there, but yeah, letters, digits, okay, underscores, that's why I put those 3 there. So we did skip one. I thought there was another one. Variables, as a last rule, must begin with either a letter or an underscore. Even though they can contain numbers, they cannot begin with numbers. Variables cannot begin with numbers, but can contain them. So yes, you can have my 25th birthday, sort of thing. Yeah, it can contain a number, it just can't start with it. So if you try to take out my right there at the beginning, you got a bit of a problem. Unexpected identifier, okay? Now you can put the underscore in there, 25th birthday, sort of thing. But yeah, it can't start with a number. So that's pretty much the whole gist of the identifier part right there. The next part here we got is constants. When you do not want others others or yourself to change existing variables. And see, this is why I don't like, I mean, I don't mind it, but it just jumps around too much because we're jumping right into constants right off the bat. And constants is one of the ones that I kind of still struggle with a little bit because I got to remember that it's in there. Okay, so what this specifically says, let's go ahead and just type this out right here so you can see it. Constants. When you do not want others or yourself to change existing variable values, use the const keyword. This will declare the variable as quotes constant, which, oops, quotes don't continue, which means unchangeable, not unchangeable, and read-only. I don't really understand what read-only actually is, but that's pretty much that right there. So here is, let's clear this out here a little bit. Something const string. We're not using that, so we can put the std string in place. I don't have it. There we go. First name is John again. Okay. So in this case right here, we have the word constants in there. So this is kind of why I know that there exists a keyword const. I also know that there exists a keyword constant express, which is a constant expression. I also know there exists a keyword constant evaluate, a constant eval. Const, though, in this case, this stuff is simply stating that the string first name is, to read this specifically, when you do not want others or yourself to change existing variable values, which would be, that's the value right there, that's the variable right there. Use the constant keyword. This will declare the variable as constant, which means unchangeable and read-only. And the example that it gives is not this right here. So let's go ahead and put in the example that they have. But this is how it would look with a string. Let's put in the example that they have and then put in the comments that they have. And I don't 100% agree with this, but const int, if we spell it right, int my num equals 15. My num, as the comment, will always be 15. Okay, that's the constant right there. Now, there is a constant expression too, and the constant expression works for expressions, not statements, or yeah, not statements like this. That's kind of the difference between it. Basically meaning that the variable 15 for this right here, if you're using my number, let's say my age, because that makes a little more sense, age, I'm going to constantly be 15. Nobody can change that data. So even if that data was in the computer and stuff, and you went to put somebody's age in there and stuff, everybody's age is always going to be 15 years old. You can't change it. It's unchangeable because of this word constant right here. But what is something that can be constantly changed? Well, something you can use this for. For one, when it comes to us humans and stuff, even going to a doctor or whatever and stuff, um, one common thing that everybody has is we're all human. So that's a constant. Okay. Um, so we could put that in there. CD string space human 1, I guess. Human always equals 1. But that would be a string. Let's go ahead and change it back to int. There we go. Human's always going to be 1. One person is always going to be 1. You can't have 2 people with 1, except for pregnant women, I guess. But in this case and stuff, I would think we'd still consider those 2 different people. The reason 2 different people is because you're checking health on 2 different people. You're not checking health on both as 1. Another constant for that would be okay. Const standard string in that particular person's sex. So are they male or female? We'll put M for this one right here, which is always going to be male. Oops, it's in a string male. Const standard string sex female equals string female. So there you go. In fact, msex, let's see, let's go with this. Msex, mzex, there we go. Okay, so msex is always going to be male, fsex is always going to be female. There you go. Constant strings, stuff that can't change, stuff that, yes, every one person in the world is always going to be 1. Every msex is always going to be male, every fsex is always going to be female. That's a constant. It's something that can't change. Even in the world, it's something that can't change. So if you have one person come in and stuff, you just declare them as whether they're male or female with an M or an F. In fact, we can change this to M F, just like that. So male or female. Change this right here to H. So we got one human, which is male or female. And there's your variable. To output this, simply put one actually let's put H string space person is M. And now, so if we were to run this right here, we would constantly have one person is male. Now, granted, we can't change what those values for those variables are, but we can kind of manipulate them. So if we get multiple people in, we have uh, int group equals h times the number of people, time people. We need to declare people, so int, actually, yes, let's see here. Yeah, int p right there. And we haven't gotten into inputting things yet, which we will get to later on. But yes, if you were to able to put in the amount of people, then yes, you can put in people times this right here, which give you however many people there are. And then you can kind of separate it and do all kinds of different things with it. So it kind of gives you an idea. The whole idea of this is stating that when you put constant in front of any kind of type, it makes the variable and the value always the same. Now, can you change it? Kind of, yes. The way you would change it is int p people equal h, capital H, and then change what the variable people are. So now people uh, equal 2. And now when you go to do this, you would change h to p. And when you save it, you're actually going to get 2 for h. Actually, let's see. H equals p. I think you can actually do that still. Leave that in there without changing that. And then run this, and I believe you're going to get 2. No, one person is male. You're still going to get 1. Because you're just changing that. How would you change that again? There's a way of changing it and stuff. I haven't. P equals H. Yeah. Anyways, we're going to get to that later on. The important thing again right here is to know that this right here makes the entire thing the same all the time. Can't be changed. So when you typing in things into a computer and stuff, you never can change it, which is something you can put into your program. If you want something to remain constant and stuff, then you would use the word const. I think it's a little bit early to start introducing constant to it, but you know what? Better late than never, I guess, or use it whenever. Anyways, next part. You should always declare the variable as constant when you have values that are unlikely to change. You should always declare variables as constants when, okay, so anytime you have something that is like this that is unlikely to ever change, then you should always declare it as constant, is what this is saying. Note on constants, when you declare a constant variable, it must be assigned a value. So yes, when you declare a constant like this, you can't just have it as this. Let me get this right here, delete. But you can't have it like that because you're missing part of the constants. In this case, you're missing the value part of the constant. You have to have the rest of it in there. Again, this is my journey through it and stuff, and I've gone back and forth, overlooked around the box. If we were talking about a box, underneath the box, inside the box, and I'm doing everything else. I'm still finding new things to this, new ways to use it. I'm not teaching this at all. This is my journey and how I have discovered this sort of thing. And I could be wrong on some of these things. I could be right on some. Well, I'm right on quite a few of these things, but I'm still learning it. That's the whole idea. Okay, so real life example. Uh, let's get a bit more practical. Often in our examples, we specify variable names to match their data types. My int, my num for integer types, my char for char types, and so on. This is done to avoid. So I'm gonna go ahead and type this down here so you can actually see it better because you may not be able to see what it's showing right here. So, however, for particular examples, so let's see, often in our examples, and yes, you can come to these websites and do this too as well. This is just kind of getting a different person's perspective of the knowledge we can learn from this. Variable names to match their data type. Put it in there right. So my int or my num for int types my char for char. But as you notice the stuff, I'm not doing it. It says to use something that matches, but and it's specifically saying in this, let's go ahead and get the rest of this written out real quick, I guess. I am not really follow along with this, and I don't. Most people do not. However, for practical example of using variables, we have created, I'm just kind of typing it out word for word right here, a program that stores different data about a college student. Okay, so right here, this is part of what it says in this thing in here. Often in our example, we simplify variable names to match their data type. So my int, my num for any kind of integer type. But as you can see, I'm not doing that. And a lot of these and stuff, when I was to declare, actually we can go and get rid of all this right here. When I was to declare integer, I'm not using my int, my num. No, I'm not using any of that. I was using lumber because we're describing lumber. We're describing what lumber represents or what this value represents, which is lumber. We're not describing what the integer represents. We're describing what the value represents, which is lumber. So this does not follow this concept. And I suggest you follow what the value is over what the integer type is right here, or the type is. In this case and stuff, it would prefer to you, this is kind of the way I just read it, I don't know. Often in our example, we simplify variable names to match their data type. So in their examples, they are. In real life, you're not going to. So they're using my int or my number to represent the type. Most of the time when you write your code, you're going to write the code so that whatever the value is, the variable name represents the value. Lumber, 50. Cost, $10. That sort of thing. At least this way and stuff, when somebody looks at it, they're going to realize, hey, so it's lumber, it's 50 pieces of lumber that they're looking for. And the cost per piece and stuff is $10. So in their examples, yes, they're going to use this. So yes, I would agree with that because they have no idea what these values may end up representing, but we're putting these more of into real life situations so it makes more sense as to what the code actually is. So in their example, let's go ahead and go through this, and it does not hurt me one bit to clear all that stuff out, rewrite it and stuff, because I'm just getting used to typing this out, seeing it again, and understanding it multiple times, more than just once. So student data is what this right here is all going to represent. So right now we are using a comment to declare what all the data below this is going to represent. And you don't have to have it right here. I could have put it up here instead. Student data instead. Either way, doesn't matter. Okay, so int student ID is 15. Int student age is 23, and they're just making up numbers right now, values. They're not actually going with anything specific. Double student fee is 75.25. Char student grade is B. Now they're going to have down here, we're going to be doing the printable variables. Here's the comment for it right here. Print basically each variable. I put get, not each. My spelling is getting terrible. Print each variable. Okay, so we're going to print each variable. Now I'm going to simplify this because I'm not just going to type all this out. There's no point in doing that. I know there's an easier way to do it. So student ID is student ID. And they're still using double quotes for this. I know that there's another way of doing that, but I'll go and follow along with examples for now. Again, there's no reason to actually do this right here, so actually I'm going to go back, erase that, tab, space, space, student age, student age, why is it giving me, oh, because it hasn't finished yet, that's why. Next one is going to be student fees and student grade. Okay, this should clear up because it's all the same output. But it doesn't. Why not? Ah, I know what I'm missing. Let's see. There. That's why it wasn't coming out properly. I knew that. Just had to look at it for a second. Kind of the whole idea of doing all this, right? Get used to doing it over and over again so it becomes second nature. So you see the mistakes you make. And there you go. You got it all. So that's one example. Calculate a rectangle. Let's go ahead and do this one too. In this case, we're going to go ahead and clear this off. I'm going to start this all over here again. We're going to put the comment right here this time. Create integer variables int length is 4, int width is 6. Calculate the area of a rectangle. Int area equals length times width, and print the outcome. I'll just go ahead and put that in there. And again, I'm not writing multiple ones out here. I'm just going to simply do what I've been doing. All right, that's the next example right there, which is another real thing and stuff. If you don't know what area of a rectangle is and stuff, you just simply write a program like this and stuff, where all you have to do is constantly change the width and the height, and it gives you pretty much everything there. Give you the number you put in for length, width, and the total area, 24. We don't know if this represents feet, inches, etc., whatever it represents, but that's kind of the idea. All right, moving on to the next part. Next part's going to be a code challenge, which we're not going to do. User input. Okay, we will pick up with this next time around. I've already gone into this for about an hour, so I'm going to take a short break and stuff, and then I'll come back and we'll do some more of this. We'll pick up right here on the next video. But for now, if you have any comments, questions, if I did something wrong, did something whatever and stuff, please mark it in there. Questions are fine. Help me to understand this. Like I said, this is my learning journey, so if you can correct me on something, that's fine. I know that this is the beginning part of this right here, so I know that there's a lot of stuff that is not covered in this section. Again, other places, my other sources include, and I will show this here in just a second. Actually, I'm already showing it, so I'll just go and leave it up there until I change this. So other sources include, again, this right here. And I've gone through this quite a bit, which is the learncpp.com. Another one is actually, no, we're going to close that out. So we're going to open this up, go to this, and I'm surprised it's taking that long. It normally doesn't take that long. Anyways, let's go and put the other one in. This one right here, which is this right here. And then this right here. There we go. Now it comes up pretty quick. And this right here, which is my education. So these four right here. W3 Schools, which, like I said, I'm not really using W3 Schools anymore. I'm only using it to show my journey through this right here, which I know that my journey at this current time and stuff is way off compared to what I'm used to now, because my journey actually includes most of this right here in content. Every purple spot is a spot that I've already gone through and read. I don't fully understand all of it yet, but I am getting through it over and over again to continue understanding it, as well as trying to understand every bit of this right here, which that is huge, because I haven't even gone through a full library yet. As you can see, there are libraries. I started with general utilities right here, and I haven't gone through all that yet. So there's still quite a bit to understand, and then also still going through all of his videos right here to understand all of his stuff. So again, so next video, I will pick right back up where I left off right here, and we'll continue going, and eventually you will finally see where I am kind of at a roadblock or stuck or whatnot, and it may eventually come to me once I get to that point. But for now, like I said, this is my journey. Continue traveling with me next time.